There is a rock floating between Mars and Jupiter, and somebody has done the arithmetic on it, and the answer they got is $10,000 trillion, 10 quintillion, a number with 19 digits in front of the decimal point. They will tell you this rock, one rock, is worth more than every economy that has ever existed on Earth, stacked end to end, going back to the first person who ever traded a fish for a flint. And the headline practically writes itself. Go up there, the story goes, drag it home, and you become so rich that the word rich stops meaning anything. I want you to hold on to that number, because in the next hour, I'm going to take it apart in front of you, screw by screw, until there is nothing left of it but a pile of bad assumptions on the floor. And I am not going to do it because the dream is foolish. I am going to do it because the dream is real, and it deserves better than a lie with 19 digits. Here's the first thing nobody tells you. That number is not a measurement. It is a multiplication. Somebody estimated the mass of metal in that asteroid, looked up the price of platinum and nickel and iron on the commodities market this morning, and multiplied one by the other. That is it. That is the whole calculation. And it is exactly as honest as walking into the Sahara, weighing the sand, multiplying by the price of a single grain of sand at a fancy aquarium gift shop, and announcing that the desert is worth 100 galaxies. The multiplication is correct. The conclusion is insane, because the price you looked up is not a property of the substance. It is not baked into the atoms the way mass is, the way charge is. The price is a relationship. It is a conversation between how much of the thing exists and how badly people want it. And the instant you change the supply, you have changed the price, and your beautiful 19-digit number evaporates like dew. Let me make this concrete, because I never want you to take my word for anything. Why is gold expensive? Not because it is pretty. Lots of things are pretty. Not because it is useful for most of history. It was nearly useless. You cannot make a plow out of it, or a sword worth swinging. Gold is expensive for one reason, and one reason only. It is rare, and it is rare in a particular maddening way. It is hard to get, and there is not very much of it within our reach. All the gold ever mined by every human being in all of history would fit if you melted it down into a cube about 20 meters on a side. A cube you could tuck under a baseball diamond. That scarcity is the whole engine of the price. Now, you fly to your asteroid and you bring home not a cube 20 meters on a side, but a mountain. You bring home 1,000 years of gold. 10,000 years. What have you done? You have not become rich. You have done the precise opposite. You have walked into the world's gold market holding an ocean, and the price has gone to the floor before your ship has even finished landing. You are now the proud owner of a warehouse full of a yellow metal worth roughly what aluminum is worth, which is to say worth making soda cans out of. You did not strike it rich. You destroyed the very thing that made your cargo valuable. You mined the value to death. And here is where it gets strange, because this is not a bug in the plan. This is the plan eating itself. The better you are at asteroid mining, the more efficiently you haul precious metal back to Earth, the faster you annihilate the price of precious metal, and the less your next load is worth, and the load after that. Success is self-defeating. The dragon's hoard, dragged into the daylight, turns into gravel. I have watched smart people refuse to understand this for 30 years, because the multiplication is so seductive, and the economics is so quiet, but the universe does not care how seductive your arithmetic is. So let us throw out the gold rush fantasy. Let us strip it down to the bare metal and start again, because that is the only honest way to build anything. We have established that bringing precious metal back to Earth to get rich is a category error. Fine. What else have we been assuming? We have been assuming the hard part is the asteroid. It is not. The hard part is the getting there, and far more brutal than that, the getting back. You have to understand the tyranny we live under at the bottom of this planet. We are sitting at the bottom of a gravity well 4,000 miles deep. To climb out of it, to put a single kilogram of anything into orbit, you must accelerate that kilogram to roughly 18,000 miles an hour sideways. And the fuel it takes to do that is governed by a piece of mathematics so unforgiving that engineers speak of it the way sailors used to speak of the sea. The rocket equation, it says in plain language that to carry fuel, you need more fuel, and to carry that fuel, you need still more, and the whole thing compounds against you exponentially. This is why a rocket the size of a skyscraper delivers a payload the size of a school bus. The rest is fuel, to lift fuel, to lift fuel. Now, flip it around. Whatever you mine up there, if your business plan is to sell it down here, you have to bring it down through 100 miles of atmosphere moving at orbital speed, which means it arrives wrapped in a sheath of plasma hot enough to vaporize most materials, and you have to slow it down without smearing it across 3 counties. The energy to go get the platinum, plus the energy to bring the platinum home, plus the cost of not destroying the platinum on the way down, can easily exceed the value of the platinum even before you have flooded your own market. You can lose money on every kilogram and try to make it up in volume, which is the oldest joke in business and the saddest. I want to stop here and tell you about a man, because this is not a hypothetical, and the history of this dream is older than the rockets. His name was Daniel Barringer, a mining engineer, a hard, stubborn, brilliant man, and around the turn of the last century, he became convinced of something his colleagues thought was lunacy. There is a hole in the Arizona desert, a near-perfect bowl nearly a mile across, and the geologists of the day, the respectable ones, said it was a volcanic steam explosion. Barringer looked at it and said, "No, that is an impact crater. Something fell out of the sky and punched that hole." And here is the thing, he was right. He was right about the universe. It is an impact crater. Today, it bears his name. But Barringer did not just want to be right. He wanted to be rich, because he reasoned correctly that the thing that made the hole was a colossal iron meteorite, an asteroid fragment. And iron has value, and a mountain of iron buried just beneath the crater floor would make him a king. So he formed a company, and he drilled. For 26 years, he drilled, sinking shaft after shaft, pouring in his money and his investors' money and finally his health, chasing a buried iron mountain that his calculations told him had to be down there. It was not down there. And here is where it gets strange and a little terrible. The asteroid had not buried itself in the desert like a cannonball in mud. It had hit the ground moving so fast, tens of thousands of miles an hour, that the impact released the energy of a nuclear bomb, and the iron mountain did not embed itself. It mostly vaporized. It blew itself apart and scattered across the landscape in droplets, and threw most of itself back into the sky. Barringer spent a fortune and a lifetime trying to mine an asteroid, and the asteroid, in a sense, had already mined itself into a fine mist before he was ever born. He died nearly broke, having proven the science and lost the bet. I think about him often. He is the patron saint of everyone who looks at a rock in the sky and sees a bank vault. He was not stupid. He was right about almost everything. He just misunderstood what he was actually dealing with, and that is the whole danger of this subject. The seduction is in thinking you already understand the thing you are reaching for. So let us actually understand the thing. What is an asteroid? And here is one of the most beautiful facts in all of science, and one I spent a good part of my life working on, so forgive me if I get warm about it. We can tell what an asteroid is made of without ever going there. We can do it from 100 million miles away with light alone. Because every substance, every mineral, every metal, when sunlight falls on it and bounces back to us, absorbs certain colors and reflects others. And it does this in a pattern that is as specific as a fingerprint. Iron-bearing minerals drink certain wavelengths. Water locked in clay leaves its own signature. Carbon compounds darken the whole spectrum in a particular way. So we point a telescope at a moving speck of light. We spread its reflected sunlight into a spectrum, and we read the composition of a mountain we will never touch. I find that more astonishing now than I did when I was 20. We are reading the mineralogy of objects in the dark across the width of the solar system by the light they happen to throw back at us. And we are not only reading them from afar. Here is a fact that I think is criminally underappreciated. We already have pieces of asteroids sitting in our laboratories, and we got them for free. They are called meteorites. Every year, fragments of the asteroid belt chips knocked loose in ancient collisions, wandering the inner solar system for ages, fall out of the sky and land in a wheat field in Kansas or on a glacier in Antarctica, where the dark stones sit on the white ice like spilled pepper, waiting for somebody to come collect them. These are not exotic objects. Museums are full of them. You have probably stood next to one, and when we cut them open and put them under the microscope, we find exactly what the spectra promised us from 100 million miles away. The iron meteorites, heavy, metallic, and when you slice and polish and etch them, they reveal an interlocking crystal pattern that can only form by cooling unbelievably slowly over millions of years. Deep inside a parent body, those are the shattered cores I told you about, the melted hearts of small worlds delivered to our doorstep with the postage already paid. And the dark, crumbly, carbonaceous ones come apart in your fingers, and they are damp with water locked into their minerals, and, as I am about to show you, stranger cargo than water. So before we have launched a single serious mining mission, nature has already been running sample return for 4.5 billion years, dropping the entire catalog of the asteroid belt onto our heads one stone at a time. We did not have to go to space to start reading the inventory. We only had to look down and pick up what fell. And when we read them, the asteroids sort themselves into families. There are the stony ones, the silicate types, the most common, ordinary rock. There are the metallic ones, the rare ones, that appear to be the shattered cores of small worlds that formed, melted, separated their iron into a center just like Earth did, and then were smashed apart in some ancient collision, leaving the naked metal heart exposed, and those are the ones that launched the 19-digit headlines. And then there are the dark ones, the carbonaceous ones, black as coal, boring to look at, the ones that never make the headlines. And I am going to tell you something now that is going to sound backwards, and I want you to sit with it, because this is the hinge on which the entire real future of this turns. The boring black ones are the treasure, not the gold, not the platinum, the boring ones. Here is what's really going on. The most valuable thing in the asteroid belt is not a precious metal. It is the single most common, most ignored, most taken for granted substance you can imagine. It is water. And I know how that sounds. Water? You can get water from a tap. You bathe in it. How is water the treasure of the solar system? Stay with me, because the answer is one of those ideas that once you see it, rearranges everything. You are thinking about water as a thing to drink. Stop. In space, water is not for drinking, or rather, that is the least of what it is. Water is hydrogen and oxygen bonded together, and if you split it apart with electricity, which you can get from sunlight, you have just made the two best chemical rocket propellants in existence. Liquid hydrogen and liquid oxygen are what flew the space shuttle. So water, that humble stuff, is rocket fuel waiting to be unzipped. Water is also breathable oxygen for the same reason. Water is drinking water, yes. Water is radiation shielding a thick layer of it around your ship, soaks up the cosmic rays that would otherwise cook an astronaut on a long voyage. Water is everything you need to keep human beings alive and moving in space, all in one molecule. And it is sitting, frozen, locked into the clays of those boring black carbonaceous asteroids by the trillions of tons. Now watch what happens to the economics when we stop trying to sell things down the gravity well and start thinking about up. Here is the number that matters. To lift 1 liter of water, 1 liter, a bottle of water, 1 kilogram from the surface of the Earth up into orbit has cost, historically, thousands of dollars. Thousands. Because of that tyranny of the rocket equation we just talked about. So a liter of water sitting in orbit is not worth what a liter of water is worth on Earth. It is worth what it cost to get it there. which is a fortune. And a liter of water that is already up there in the first place, that you never had to drag up out of the gravity well that you found already floating in space on an asteroid. That water is worth that same fortune, minus the cost of fetching it from one place in space to another, which is enormously cheaper than fetching it up from a planet's surface. Do you see it? The value was never in the substance. The value is in the location. It is the oldest rule in real estate, and it turns out to govern the solar system too. Location, location, location. A glass of water on Earth is worth nothing. The identical glass of water, 300 miles up, is worth more than its weight in almost anything, not because the water changed, but because where it is changed. The asteroid miner of the future does not get rich digging up gold and bringing it down to a market that does not need it. The asteroid miner gets rich selling water, fuel, air, shielding to the other people up there who are trying to go somewhere and who would otherwise have to pay the brutal tax of hauling every drop up from Earth. And here's where it gets strange again, in the best way. This means the entire economy of asteroid mining is inverted from the fantasy. Nothing comes down. The whole point is that nothing comes down. You are not building a pipeline from the sky to Earth. You are building gas stations in space. You are building the supply depots along a road that does not exist yet, betting that the road is coming. The asteroids become the fuel cans you cached in the desert before the wagon train set out. Your customer is not the jewelry market in New York. Your customer is the ship that is trying to get to Mars and does not want to carry its return fuel the whole way out. Your customer is the future, and the future does not pay in the metals fantasy. It pays in the difference between hauling water up a 4,000-mile cliff and finding it already at the top. And once you see the water that way, a second idea follows that is almost too neat to trust, except that the logic is airtight. If the water frozen into an asteroid is rocket fuel waiting to be split apart, then the fuel you mine can power the ship that goes to mine the next asteroid. You stop hauling propellant up from Earth at ruinous cost for every single trip. You bootstrap. The first load of water buys you the fuel to reach the second rock, which buys you the fuel to reach the third, and somewhere along that chain, the whole enterprise quietly stops being a thing you have to supply from the bottom of the gravity well and becomes a thing that supplies itself out there off the planet, feeding on what it finds along the way. That is the threshold that changes the human story the moment the venture no longer has to be fed from below. We are nowhere near it. I want to be honest with you about that. But it is not forbidden by any law of physics. It is forbidden only by problems of engineering and money and political will, and those are exactly the kinds of walls that our species has a long, stubborn, magnificent history of climbing over. The dream was never that an asteroid is a vault full of gold to drag home. The real dream, the one worth a life's work, is that an asteroid is the first link in a chain that finally lets us stop carrying the entire crushing weight of every voyage up out of this well on our backs. It is the difference between a traveler who must pack every drop of water he will ever drink and a traveler who has learned where the wells are. Let me give you the thought experiment that finally made this click for me, because I resisted it for years. I, too, was seduced by the metals. Imagine the gravity well of the Earth as an actual physical well, a stone shaft, 4,000 miles deep, and you are at the bottom, and everything you want to do in space requires hauling water up to the rim on a rope, hand over hand, kilogram by kilogram, at agonizing cost. That is the situation we are in right now. Every drop of water in space today, we lift it out of that well. Now imagine you discover that scattered around the rim of the well, just outside it, in the easy country up top, there are wells already full of water that you never have to lift at all. You just have to walk over and dip your bucket. That is what a carbonaceous asteroid is. It is a full bucket sitting on the easy side of the cliff you have been killing yourself to climb. The metallic asteroid, the 19-digit one that is a vein of gold at the bottom of a different, deeper cliff that you have to climb down into and haul back up. One of these is a business. The other is a press release. And which asteroids are sitting on the easy side of the cliff? Not, for the most part, the famous ones way out in the main belt between Mars and Jupiter, the big ones, the 19-digit ones. Those are a long and brutally expensive haul. The asteroids that matter for any of this in our lifetimes are the near-Earth ones, the thousands of bodies whose orbits swing in close to our own that we have been discovering at an accelerating clip ever since we finally got serious about scanning the sky for them. And here is the part that surprises everyone, including me when I first worked through the numbers. Some of those near-Earth asteroids are energetically easier to reach than the surface of our own moon. Easier. Because reaching a place in space is not about distance. Space does not charge you by the mile. It is about changes in velocity, about how much you have to speed up and then slow down. And a small asteroid that gently shadows Earth's orbit demands almost no slowing at all. It has essentially no gravity to fight on the way in and none to climb back out of on the way home. You drift up alongside it, you do your work, you drift back. The moon, by contrast, has enough gravity that landing on it and lifting off again costs you real propellant in both directions. So the universe has played a quiet little joke on the headline writers. The treasure they are drooling over out in the deep belt is among the hardest things in the solar system to get to. And the humble, water-bearing, utterly unglamorous rocks drifting right past our own doorstep, the ones nobody will ever write a headline about, are in many cases the lowest hanging fruit there is. The cosmos rewards the patient reader of the fine print, and it has never had much mercy for the man who only read the number. I told you I would give you the history, the real history, and I have not been to space, so let me tell you what we have actually done, because we have done more than people remember. The first time human eyes saw an asteroid up close, really saw it as a world and not a point of light, was when a spacecraft of ours flew past one on the way to somewhere else. We saw a battered, cratered, potato-shaped little world. And then a few years later, we flew past a second one and discovered, to everyone's astonishment, that this asteroid had its own tiny moon, a speck orbiting a speck. Nobody had predicted that. We had assumed asteroids were too small, too feeble in their gravity to hold anything. We were wrong. And that is the pattern I want you to notice. Every single time we have gone to look, the asteroids have been stranger and more individual than our theories said. And here is the wrong turn, and I include myself in the we who took it. For a long time, we pictured an asteroid as a solid chunk of rock or metal, a boulder, a thing you could land on, drill into, quarry like a granite cliff in Vermont. That picture is, for many asteroids, simply false. When we measured their densities carefully, the numbers came back too low, far too low for solid rock. The only way to explain it was to admit that many asteroids are not solid at all. They are rubble piles, loose aggregations of gravel and boulders and dust, held together not by the strength of stone, but by the faintest whisper of their own gravity, with as much empty space inside them as material. A flying heap of debris that the eons have gathered into a loose ball. And this is not a footnote. This is the whole engineering problem standing up and slapping you in the face. You cannot drill a rubble pile the way Barringer tried to drill the Arizona desert. Push too hard and the whole thing shoves away from you, or comes apart in your hands, or swallows your drill into a void. We do not actually know with confidence how to mine a body that has almost no gravity and almost no solidity, where there is no down to dig toward, where every scoop of regolith you disturb floats up around you in a permanent cloud that never settles because nothing settles when there is no weight. How do you anchor a machine to a beach ball of gravel in a vacuum? How do you contain dust that will not fall? We have theories. We have not solved it. And I find that not discouraging, but thrilling, because it means the problem is still open, still alive, still waiting for the person clever enough to crack it, and that person might be sitting in this room. Let me make that problem physical for you, because it is easy to wave away and genuinely hard to do. Picture yourself as the miner. You are standing no. There is no standing. There is no floor. There is no down. You are floating beside a mountain of loose gravel the size of a stadium. And the mountain's gravity is so feeble that if you took one ordinary walking step, you would launch yourself clean off it into space, never to return. And you want to dig, so you swing a pick. On Earth, the pick bites the rock, and the rock holds still because the whole planet is holding it still for you. Out here, there is no planet to hold it. You swing the pick, and the pick does not so much strike the asteroid as the asteroid and the pick strike each other, and you, gripping that pick, are flung backward off the surface while the chunk you dislodged drifts off in the opposite direction. And now you are tumbling slowly in the dark beside a gently expanding cloud of the very material you came all this way to collect, watching your profit disperse into the vacuum. Every instinct your body owns, every reflex about weight and leverage and bracing and digging, that 4 billion years of evolution at the bottom of a gravity well hammered into your bones is wrong up there. We have to invent an entirely new way to do the oldest work there is, the moving of rock from one place to another, for a place where rock refuses to behave like rock. Nobody has done it yet. And the first person who does it well will have figured out something genuinely new under the sun, and that, far more than any nugget, is the thing I would want my name on. And before we leave those boring black rocks behind, I owe you the strangest fact about them, the one I have chased through a good part of my own working life. I told you the carbonaceous asteroids are wet, full of water. They are also full of carbon. That is what carbonaceous means, and not merely carbon as soot or graphite, but carbon assembled into molecules, organic molecules. When a meteorite of this kind fell near the town of Murchison in Australia, and scientists carried the fragments into clean laboratories and dissolved them and looked carefully at what was inside, they found amino acids, the building blocks of proteins, the very alphabet that every living thing on this planet is written in. Now, let me be careful, because careful is the entire job. They did not find life. Not bacteria, not fossils, not little green men. They found the raw chemical letters from which life assembles its words, manufactured out in the cold and the dark by ordinary chemistry, with no biology anywhere in sight, and then mailed to Earth inside a falling stone. And here is the part that raised the hair on my neck the first time I understood it. They found more kinds of amino acids than the 20 that life on Earth actually uses. The asteroid had been running its own chemistry experiment with a richer alphabet than the one life down here ever settled on, cooked up in the void and delivered to us special delivery. Now hold that beside everything else we have said tonight. The same late rain of asteroids that frosted this planet with gold may also have frosted it with the building blocks of biology. The asteroids may not have only delivered the metal in your ring, they may have delivered some part of the chemistry that became you. And if that happened here, it happened everywhere. Every young world getting pelted with carbonaceous rubble is getting the same care package, the same starter kit, dropped on its head. That is not a mining question anymore. That is the question of whether we are alone in the universe, riding quietly on the back of a question about what a rock is worth. I told you these things connect. I did not tell you how far down the connection goes. But I do not want to leave you with mere engineering, because there is something underneath all of this that is far larger, and I would be cheating you if I did not say it plainly. I want to ask you a question that sounds like it has nothing to do with mining, and then I am going to show you it has everything to do with it. Where did the gold come from? The gold in your wedding ring, the gold in the wire of the device in your pocket. Where did it come from physically on this planet? Here is the thing that should keep you up tonight. It should not be here. When the Earth was young and molten, all the way through, the heavy metals, the gold, the platinum, the iron, being heavy and chemically fond of iron, sank. They drained downward through the molten planet toward the center, and they pooled into the core 4,000 miles beneath your feet, where they remain, locked away forever, utterly out of reach. By rights, the crust of the Earth, the thin skin we live on, and mine should have been swept almost clean of gold and platinum. They should all be down in the core with the iron. And yet, here is a gold ring on someone's hand. Here is platinum in the catalytic converter of every car outside this building. Why? How did it get up here, near the surface where we could find it? The best answer we have, and it is a stunning one, is this. After the Earth's core had finished forming and sealed itself off, after the door to the basement had closed, the planet was bombarded. A late rain of asteroids and the leftover debris of the solar system fell on the young Earth for hundreds of millions of years, and they delivered a fresh coat of metal onto the crust. A late veneer, the geologists call it. A frosting of asteroid metal laid down on top of a planet that had already buried its own. And that frosting, that delivery from the sky, that asteroid metal that arrived too late to sink into the core is, in large part, the gold we mine, the platinum we mine. It is asteroid metal, it always was. Sit with that, because it is not a metaphor, and I am not being poetic. Every gold rush in human history, every glittering vein, every nugget panned out of a California stream was asteroid mining. We have been mining asteroids for the entire history of our species. We just let gravity do the delivery 4 billion years ago, and we have been picking through the wreckage ever since. The asteroids have been raining wealth on this planet since before there was a planet to rain it on. The only thing that is new, the only thing we are actually debating tonight is whether we go up and choose which deliveries we want, instead of waiting the way we always have for them to arrive on their own schedule. And here is where it gets strange one final time, and this is the part I cannot make comforting, so I will not try. The capability to go to an asteroid and nudge it, to change its path, to bring it closer, to put it where you want it so you can work it, is precisely, exactly, atom for atom, the same capability as nudging an asteroid toward us. The technology of mining and the technology of planetary defense and the technology, let us be honest, of planetary attack are not cousins. They are the same technology wearing different intentions. The engine that lets you tow a water-rich rock into a convenient orbit for your gas station is the engine that, pointed differently, lets you tow a mountain onto a city. We have spent this whole hour talking about money, and I have been steering you the whole time toward the moment when you realize that the money was never the most important thing in the room. The most important thing is that the same key opens the treasury and the armory, and we are about to forge that key, and we have not remotely decided who gets to hold it. So, could we mine asteroids for money? Now you can answer it yourself, because you have done the work. Could we get rich hauling gold and platinum down to Earth? No, almost certainly not. And anyone selling you that 19-digit number is selling you the desert by the grain. The market would collapse under its own cargo, and the gravity well would eat the profit on the way down. Could we get rich selling water, fuel, and air and shielding to a civilization that is finally trying to leave Earth by caching it at the top of the cliff so nobody has to haul it up? Maybe. Genuinely, maybe. Not soon, not easily, not before we solve how to grip a rubble pile and tame dust that will not fall. But maybe. And the first fortune up there will not be made selling to the people down here who want jewelry. It will be made selling to the people up there who want to go farther. The customer is not the past. The customer is the direction we are headed. But I will not let you leave with a tidy answer, because the tidy answer is the lie I have been fighting all night. Here is the real question, the one I want lodged in your chest on the drive home, the one I do not have an answer to. We have established that the wealth was always coming from the sky. We have established that we are made, in part, of metal that fell. We have established that the dinosaurs, the great rulers of this planet for 150 million years, were ended by an asteroid that arrived on its own schedule with no warning, because nobody was watching the sky and nobody could have done anything if they were. The asteroids have been writing the story of this planet from the beginning, delivering our gold, and on at least one afternoon, deleting the dominant life on Earth in an instant. So the question is not, can we afford to mine the asteroids? The question is the one Barringer never thought to ask while he was drilling his shafts. Can we afford to remain a species that lives at the bottom of a single well, on a single world, with every egg we have ever had in one fragile basket, waiting the way we have always waited for the next delivery to arrive, whether we are ready or not? The rock between Mars and Jupiter is not worth $10,000 trillion. It is not worth anything at all until somebody goes and gets it. And the moment we can go and get it, the moment we can reach up and choose the dollar figure, stops being the point. And a far older question, the only question that has ever really mattered for anything that wants to keep living, takes its place. Not what is it worth? The question is, are we going up or are we going to sit at the bottom of the well and wait?